All right, we're going to start part 2 of Unit 1 by looking at what matter is and the different types of matter that exist. And I want you to know this concept map. I know it's a little blurry, but all things that have mass and take up space are considered matter. It's going to be from the smallest to the largest objects, so that's quite a bit. Matter can be broken down into 2 separate categories, and we're going to talk about what makes each of these different, but substances and mixtures are going to be the 2 types of matter that exist, and then from there they can be broken down even further. So we're going to look today in the notes about mixtures, and there's 2 different types, what makes heterogeneous and homogeneous different. And then substances. There's 2 different types of substances. What makes an element different from a compound and vice versa. Definitely a concept map you should be able to know, as it's kind of the main idea of how matter is organized. So we're going to start, first of all, with what matter is, and I already mentioned that it is anything that has mass and takes up space. So again, the smallest of matter would be atoms. They're your basic building block. Everything is made up of atoms. And matter can be found in nature in 2 main groups. And those would be, if you think back to that concept map on the previous screen, substances and mixtures. Okay, we're going to look at substances first. So just a few characteristics of a substance. They are pure samples of matter. So substances are considered pure. Sometimes they're going to be called pure substances. And they all have a definite composition. Now think where the word definite, and what that means that it has a specific composition. It doesn't change. It is the same all of the time. And again, think back to the concept map. Substances can be broken down into 2 smaller categories. They were elements and compounds. So now we're going to take a look at elements. What makes an element, and then we'll look at compounds so that we can see how they're different. So elements would be things like sodium or oxygen. These are made up of only one kind of atom. So sodium is made up of only sodium atoms, oxygen only oxygen atoms, and it is not possible to divide an element into anything smaller. So sodium can't be divided up into other elements. It is only sodium. And there are 118 known elements. Now, one of the ways that you can check if something is an element is by looking at a periodic table of elements. And you'll be given a paper in class, and we'll talk about it and use it a lot throughout the rest of the trimester. And there's also a large poster in the room of the periodic table of elements. You're going to notice that a chemical element has a symbol that goes with it, and the symbol is usually 1 or 2 letters. If it's a 2-letter symbol, the first one's always capitalized. And for most symbols, you can kind of figure out the name of it by the symbol. The symbol is derived, or the symbol comes from the name of the element, except in a few cases the symbol actually comes from the ancient or Latin word for that piece of material. So for example, iodine, capital I. That one's kind of an easy one. O, oxygen. But there are some that are kind of unique. For instance, sodium is capital N, lowercase a. So how in the world did they get Na from sodium? And that's because that one's actually taken from the Latin word naturium, which is where the Na comes from, first 2 letters of the Latin name. So if the symbol doesn't make sense, that's more than likely the reason why. Now let's look at compounds. Okay, compounds are another type of pure substance, but they're different from elements. One of the things that makes them different is that they are made up of more than one atom. For instance, water. It's made up of hydrogen and oxygen. So it's 2 elements that have been chemically bonded together. And not only bonded together, but bonded in a specific ratio. So water always has 2 hydrogens, always has 1 oxygen. If you change that to H2O2, it's not water anymore, it's actually hydrogen peroxide. So the amount of the elements makes it unique and makes it a certain type of compound. So that's important. And compounds also have a definite composition. Similar to elements in that way, all substances have a definite composition. So some other examples, we mentioned water, carbon dioxide is another one. You can separate compounds chemically. You can separate the hydrogen and the oxygen. Since they are bonded together, you can unbond them. Now, when you look back at your concept map, matter was broken apart into mixtures and substances. So we're going to take a look at mixtures and how are they different from substances. Well, a mixture is actually two or more substances that have been mixed together. And they're going to retain their chemical identity. So the two individual materials that you're bringing together are still going to maintain their chemical properties. They're not actually bonded together. Unlike a compound where they are bonded, a mixture, they're just mixed together. They're not actually chemically bonded. And we have to have different substances. So just taking water and mixing more water in, that's not a mixture. But if you take water and you take salt, both of which are compounds, and you mix those together, then you have a mixture. We have two different types, heterogeneous and homogeneous, and we'll talk about what makes those different here in a minute. And the big key difference between a mixture and a substance is the composition. Mixtures have variable, meaning they can change. You might make some salt water at your house, I'll make some salt water at my house, and maybe we use different amounts of water, different amounts of salt, but we still call it salt water, even though the amounts of them might be different. Whereas water is water, and it has to be H2O. So a mixture composition can vary, but in substances, composition cannot vary. And again, we have our two categories, heterogeneous and homogeneous. We're going to look at heterogeneous first. The prefix hetero means different. So in a heterogeneous mixture, you have an uneven distribution of particles. So when you mix the two substances together, you very well might be able to see the difference. If a microscope, you could see the different parts that make up blood. Good old school lunch, peas and carrots, you can see the difference between the peas and the carrots. Chicken noodle soup, your recipe might be different than my recipe, but we still call them chicken noodle soup. You can see the individual particles, the chicken, the noodles, the broccoli. I don't know who puts broccoli in their chicken noodle soup, but okay. But those are heterogeneous, different particles. They're not evenly mixed. You can see most of the time the varying pieces. Suspension would be a specific heterogeneous mixture. If you take a look at this picture of muddy water, you can kind of tell that it's been sitting for maybe a few hours, maybe a day. You can see all the sand and kind of muddy stuff at the bottom and then the layer of water at the top. So a suspension is a heterogeneous mixture with large particles. Visibly, you can see the sand separate from the layer of water. The particles are visible and they're going to settle when you let it stand. And sand water, like the picture. All right, let's look at homogeneous mixtures. Homogeneous mixtures, the prefix HOMO means same. So in a homogeneous mixture, everything is going to be evenly mixed, evenly distributed. You are not going to be able to see one particle versus another. So there's the uniform composition. It looks the same. We have things like salt water, assuming you don't use too much salt, and it's all evenly mixed. Stainless steel, it's not an element. Stainless steel is a mixture of two things that are melted and mixed together. You can't see one metal versus the other. There are two types of homogeneous mixtures. Solutions. Solutions are what we most commonly use in chemistry. So we need to know what the two parts to a solution would be. We have a solute. This is the substance that is present in the smaller amount. It's the one that you're going to dissolve. And then we have the solvent. The solvent is usually water in many cases, but it's present in larger amounts. And it is what's doing the dissolving. So for instance, Kool-Aid, something common we can relate to. It's a solution. It's made of water and sugar, and we usually have some type of flavoring packet. So you have water that would be the solvent. You have the flavor packet and the sugar. Those are being dissolved into the water, so that would be the solute. For instance, a pool, the YMCA pool, that's a solution. It's not 100% pure water. It's got chlorine dissolved in there, so the chlorine would be the solute, the solvent being the water. Now our last slide is another type of homogeneous mixture. This one's called a colloid. Colloids have medium-sized particles. Solutions are the smallest, colloids are medium, suspensions have the biggest particles. And so when you hit a colloid with light, the particles are large enough that the light cannot pass straight through it. And so you get what we hope for on some mornings, a fog. You can't see, you try to put your lights on, it doesn't cut through it. And that's because fog is a colloid. Fog and smoke are both colloids. Excuse me. When light hits them, it doesn't cut through it. The particles actually cause the light to scatter, and it makes driving even harder. So we also have smoke. There's some more fog. Those would be examples of colloids as well.